So we're starting chapter 5, which is geometrical applications of differentiation. So we are differentiating again rather than anti-differentiating. Exercise 501 is about increasing and decreasing curves. So this first curve I've drawn here, we call it increasing here. So it's increasing from negative infinity to A. It is decreasing here, because as you go from left to right, it's going down. So it's decreasing from A to B, and it is increasing when X is greater than B. So between B and infinity. So we just talk about the X values here for which it's increasing and decreasing. This one here, it always increases. It never comes back down. So we call it monotonic increasing. In the same way, this one is monotonic decreasing. So what ends up happening is when a curve is increasing, the gradient is positive. So the derivative is positive. When a curve is decreasing, the gradient is negative, so the derivative is negative. If the gradient is 0, so the derivative equals 0, then the curve has what we call a stationary point. You'll be asked to find stationary points, so you differentiate and you make it equal to 0. So in the first example, we have to find the values for which this function is increasing. So the first thing we do is we differentiate. So the derivative of x, so 2x plus 2. And we want to know where it's increasing, so we want to know where that's greater than 0. So minus the 2 off each side, 2x is greater than negative 2. Divide by the 2, x is greater than negative 1. So this curve, it is a parabola. It increases when the x values are greater than negative 1. Question 2 is find the stationary points for this function here. It's a cubic function. So I'm going to start by finding the derivative. So dy dx equals, so 3x squared minus 2x minus 5. And because it's a stationary point, I want to know where does that equal 0. Now I'm going to need to factorize this, so using PSF. Now I've already done that. The answer is x plus 1, 3x minus 5 is equal to 0. So obviously x equals minus 1 or x equals 5 over 3. Now for a stationary point, you must also find the y value. And you do that by substituting those values back into the original function. So for x equals negative 1, y will be negative 1 cubed minus negative 1 squared minus 5 times negative 1 plus 4, which equals 7. And when x equals 5 on 3, in the same way, y is equal to negative 67 on 27. So our stationary points are negative 1, 7, and 5 on 3, negative 67 on 27.